Okay, we're going to be talking about the relationship between orifice nozzle, water pressure, abrasive, cutting speed, horsepower of pump, everything that actually goes into giving you the power that you need to cut with a water jet. And if you understand this, it'll help you be able to make a wise decision when it comes to selection of pumps, number of cutting heads, and the actual combination of what you need to be able to get the optimum out of your water jet cutting system. Okay, so what we're going to talk about is the different relationships between quality and edge. Alright, so what we're looking at are different quality finishes. We call this normally a Q1, 2, 3, 4, or 5. Or you might find that some people call it extra fine going through to extra rough, or every company has a different way of describing it. You'll see that the finish here is pretty rough through to a finish here that is very smooth. The intention is that at this end of the scale it's not worth going any slower, because you're going to end up getting a wider curve at the bottom than you do at the top. And if you go to the other end of the scale, it becomes so rough that you're going to have a hammer to break it out and separate the pieces. What's interesting to note is that the difference in cutting speed between the rough end and the smooth end with water jet cutting is about 400%. So if I was cutting at 1 inch a minute here, I could potentially be cutting at 4 inches a minute as a rule of thumb and still be getting separation. That's important to understand, that there is a huge variance in cutting speed with water jet. So we want to maximize the power and then be able to get the correct speed to be able to get the right finish, the right edge, the right amount of taper. Okay, so this is not necessarily the best set of photos, the rough finish right through to the fine. Let's talk about pump capacity. As a rule of thumb, a 50 horsepower pump will produce about 1 gallon a minute of water at 55,000 psi. It is a relatively straight line relationship. That means that if you double the horsepower, if we went from 50 horsepower to 100 horsepower, we'd go from 1 gallon to 2 gallons a minute of water at 55,000 psi. So conversely, if we went to a smaller pump, in this case a 30 horsepower, you're going to get about 0.65 gallons per minute. The actual amount of water that you get from pumps does vary from pump to pump. Some pumps will give you a little more. Knowing that a 50 horsepower will give us 1 gallon a minute of water, let's go and see what size orifice. This is the orifice diameter here. This is the nozzle diameter. This is the amount of abrasive that would be optimal as a guide that would give you the most cutting power. What we are trying to do is get the most cutting power out of a water jet. So let's presume we have a 50 horsepower pump. We know it gives us 1 gallon a minute. Let's go down the list here and we'll see if we go just shy of a gallon, 0.959 gallons a minute, come across is a 14 thousandths orifice. So at 55,000 psi, I come across a 14 thousandths orifice is what I would use, and a 14 thousandths orifice is going to consume the full gallon a minute being produced by a 50 horsepower pump. So if I wanted to cut with 2 heads and I had a 50 horsepower pump and I had 1 gallon a minute, what I would do is I would look for half a gallon a minute, because if I'm going to take the gallon and split it between 2 heads, of course half a gallon is going to go to each unit. Go to my half a gallon unit, come across, and there we have a 10 thousandths orifice. With a 30 thousandths nozzle would be the optimal combination, 0.65 to 0.7 pounds of abrasive per minute. Let's say I wanted to run 4 heads and I had a 50 horsepower pump. A 50 horsepower pump produces 1 gallon a minute. I want 4 heads. I'm going to split it 4 ways. I'm looking for 1/4 of a gallon per minute. There I am. And I could see that a 7th thou orifice consumes 1/4 of a gallon a minute of water. So 4 7s or 2 10s or 1 14 would be the orifice sizes that would consume the 1 gallon a minute of water being produced by a 50 horsepower pump. So let's just recap and go back 1 slide. We've talked about a 50 horsepower. What about 100 horsepower? If I had a 100 horsepower pump, I could produce 2 gallons a minute of water at 55,000 psi. So if I now have 2 gallons a minute of water at 55,000 psi and I wanted to run 1 head, I would go to as close as I could to 2 gallons. There I am, 1.957. I'd come across and I could run a single 20 thousandths orifice with a 100 horsepower pump. Now, people don't normally do that because the stream becomes much bigger and it becomes less efficient. So why would you buy a 100 horsepower pump? You'd buy a 100 horsepower pump instead of buying 2 50s, because a single purchase of a 100 horsepower pump is lower in price than purchasing 2 separate 50 horsepower. So again, I could take a 100 horsepower pump. If I split it between 2 heads, in other words, I took the 2 gallons a minute of water that was being produced by the 100 horsepower pump, divided it into 2 cutting heads so that each head had about a gallon a minute, I'm back to running a 14 thousandths orifice. So a 100 horsepower pump would run a single 20 or a 2 14s, and of course it would run anywhere between 14 and 20. So if you're doing a lot of very thick cutting, and I'm talking 6, 7, 8, 9, 10 inches, a lot, you might want to put a 16 thou orifice or 17. Well, a 100 horsepower pump is going to easily do that and more. Okay, let's go to the next slide. What is the effect that pressure has on cutting? You'll notice that if I'm at low pressure, and as I increase my pressure, so I'm going to cut faster. This is all based on cutting 1/2 inch thick stainless steel with a Q2 finish. Remember, a Q2 finish was a fairly rough finish that we looked at earlier. A 10-30 orifice nozzle combination from the previous chart. If we go to a 10-30, it's about 1/2 a gallon a minute. That means it's the equivalent of running a 25 horsepower pump, consuming 1/2 a gallon a minute. Or if you had a 50 horsepower pump, you could be running 2 of these heads. So when we come along here, we can see 1/2 inch thick stainless steel, 55,000 psi, 10-30 orifice nozzle combination. We are cutting just over 4 inches a minute. If I simply take a 50 horsepower pump and put all that energy, the 1 gallon a minute, to 1 head, I'm going to be able to cut closer to 8 inches a minute. What's interesting is in thinner materials that 2 of the smaller cutting heads, well, if I take a gallon and split it between 2 heads, it'll normally come out to more than taking all your power and putting it through 1 cutting head. Alright, so here we have the Waterjet feed rate calculator, and here's a couple of numbers, and this is on the internet. You can download it and study it and play with it. Orifice nozzle combination 10-30. Alright, here we've got 60,000 psi. Let's go and cut mild steel. Let's actually go to this number. Let's go to stainless steel, and let's make it 1/2 an inch thick. You'll notice, and if I just pick a number that at our average or middle cutting speed, we're at 3.8 inches a minute with a 10-30 orifice nozzle combination. If I went and I changed that to a 1440, you'd see that it came to 5.7 inches a minute. So if you take all your 1 gallon a minute and you focus it into a single 14 thousandths orifice, you are going to cut faster, 5.7 inches a minute versus the 1030, which is 3.8 inches a minute. So you will cut faster putting your power into a single head. However, if you took your gallon a minute and you split it into two 1030 heads at 3.8 inches a minute each, that means that you'd be cutting at the equivalent speed of double this, which would be 7.6 inches a minute. So two 1030s, 150 horsepower pump, 1 gallon a minute, split to two heads in 1/2 inch thick stainless steel is going to give you the equivalent of 7.6 inches a minute of cutting. If I go to a 1440, you're at 5.7. So in thinner material, it pays to split your 1 gallon a minute into two heads as long as you have more than one part, and you'll produce more product. So that's just an interesting thing that you do want to be aware of, and that's why Waterjet believe so strongly in having a 50 horsepower pump with two cutting heads. Let's just get back to our chart here. So that as you increase your pressure, you can see that you can increase your cutting speed. Just a side note, I have a friend that's selling a digital camera. It was her husband's, but unfortunately he died recently during his holiday in Spain. She doesn't want to keep the camera and could do with some cash. The camera takes pretty decent photos. For example, this last photo that's attached. If you're interested, if you could give me a call, please. Okay. One other thing we want to take into account is the amount of garnet that is used, and is there an optimum amount of garnet to give you maximum cutting power? And the answer is yes. If we take a 720 orifice nozzle combination, what's happening is as we put more abrasive into the system, you can see from zero abrasive, you don't cut at all, 1/2 inch thick stainless steel. You start to increase your abrasive flow. You immediately start to cut faster or start cutting. As you put more abrasive in, you start to choke the system, and as a result, cut slower and slower. So there are optimum numbers, optimum values of abrasive that you want to be able to set your delivery hopper to be able to achieve the best cutting speed.